In this experiment, we are going to learn how we can implement an integrator or a differentiator using op-amps. So here is the circuit that you need to build, and here are the elements that you're going to use. Make sure that you make the ground connection for the positive input of the op-amp, which is pin 3 of the op-amp. And let's move to the circuit and see how we build the circuit. This is the integrator circuit, which is in part 3.1. So again, you need to make sure that you have the supplies connection for your op-amp. This pin 8, and pin 4. Pin 8 was positive VCC, pin 4 was negative VCC. Pin 3, according to the schematic in figure 1, needs to be grounded, and here is the connection of ground, and here is the connection of the ground, like previous experiment. This is the grounds from the analog discovery. I have made another ground here. I have made a connection with this wire, yellow wire here. This is again the ground. These are the grounds. The orange one and the blue ones are the grounds of the oscilloscope. According to the figure 1, we have a 1 mega ohm resistor, as you can see here, between pin 1 and 2, a 1 micro capacitor between pin 1 and 2, and there is a 10K between 10K resistor between pin 2 and the input. Input is the yellow line, the waveform generator from the analog discovery, and the white one, as I said, is the negative supply for the op-amp. This blue one is the positive of the oscilloscope to see the input, and this orange one is the another channel, the first channel of the oscilloscope, to see the input. So nothing else remaining here to explain. Just make sure that you have made this ground connection for pin 3, because this is a frequent mistake that the students make. Now let's move to the Waveform software. So I need supplies again for my op-amp, positive 5, negative 5. I need a waveform generator. In question, you have been asked to have a sine wave with 15 Hertz and 5 volt peak to peak, which means 2.5 volt amplitude. And let's run this and see the output. Cosine from a to change the square signal and see the angle. And here is correct. Iteration of the next part of the question, 3.2, is asking you to change the frequency to 100 Hertz and 1 kilohertz and notice the effect. So there's nothing special here to do. You just need to change the frequency in Waveform software and see the effect and explain it. Next part of the question, part 4, is the differentiator circuit. The very important note here is that this C1 here is 0.0 0.01 microfarad, not 0.1 or 0.01 microfarad. So the correct value is 0.001 microfarad. And you make sure to ground a pin 3 when you're building the circuit. So I'm moving to the circuit and see how we build the circuit. Here you can see the circuit. Again, we have the supply connections, pin 8 and pin 3, the white wire and red wire here. And then other connections like ground are like before, and this is the wire that is providing 2 grounds like before. And this wire and this wire, the orange here and blue here are the grounds of the oscilloscope. You have again need to, as I mentioned before, wire the pin 3 of the op-amp. There is a 1 mega ohm resistor between pin 1 and 2. There is 0.001 microfarad, again 0.001 microfarad capacitor between pin 2 and a connection here. Then from this node you have a 10K to the input. Input is provided with this wire, waveform generator, the yellow one, and this is the oscilloscope to see the input. You want to see the input, and this orange one is to see the output, the oscilloscope channel 2 to see the output. So for this part we need to provide the 100 Hz 5 volt peak to peak voltage. Then we have the square wave and triangle wave. So wave generator 100 Hz 20 volt 2.5 volts amplitude, which means 5 volt peak to peak sine wave. Turn on the supplies, waveform generator and oscilloscope, and move to oscilloscope. You need to explain what's happening here. Then we move to waveform generator. This part, this time square, as you have been asked here. And you can see in the output, you need to explain what you're seeing here. What are the outputs, what kind of waveforms are the outputs. Then you have the triangle, and you see that you need to again explain what you're seeing in the output. The next part of the question is asking you to change the frequency. Nothing special here, you just need to change the frequency and explain what changes you see in the output in comparison to what you had before.